Hey everyone, today I'll be presenting my project on RTOS. It is an AI native runtime which is used for computer-centric operating systems with increase in AI-based computations. So what we're trying to do is there's a big shift in computing recently, where with the evolution of LLMs and agentic layers, the burden falls towards the CPU, where the current architecture is situated in such a way that there's CPU, there's GPU, and there's a shared inference, shared interface where CPU communicates with GPU in order to do the task that has been scheduled to the CPU. So, for example, if a work's been created, the work goes to CPU, and the CPU transfers this high computational work to GPU, which executes in parallel and returns the output to the shared interface, which is again being pushed to CPU. This is the whole cycle that works. But this cycle couldn't be any latency influence. So in order to eliminate that shared inference, we are creating a concept, we are creating a paradigm for refining this OS, where a runtime is situated, where the whole computation, apart from security and boot loading, is directly falls under GPU. So this core system is being handled by an embedded AI intelligence, where a native system component to assist system level decision making. So the tech stack that we use here is Go and Rust for the main simulation and kernel launches. So this is the purpose of the project, to reduce CPU intervention and optimize data movement and adaptive scheduling. This is the proposal, where it's 5 different planes are there. First one is the control plane, which is responsible for the initialization and the security boundaries. It is a safety layer apart from the safety from the CPU. And the second and the important one is the runtime layer, GPU runtime layer. So this handles all the incoming tasks, the scheduler, and the operation involved in memory, directly to the main runtime. So the RTOS OS API, this is the OS runtime that has been used as an interface for AI HPC workloads. This submit tasks without direct hardware interaction. So next we go for GPU and memory management. So after RTOS schedules every single a workload to the GPU. So this memory management coordinates with memory to allocate each individual threads for the GPU runtime. So, and next we have the integration, where the complete system is performed in such a way that the memory has been optimized, the computation has been optimized based on this decision maker. So this is, and out of all this we can't create a separate OS that is completely used for GPU alone. So what we did was we used Linux as base, and we built our native runtime on top of it. Yeah, so what are the expected results for this particular solution? So we'll have significant reduced latency, and we have high scalability. Since this is a runtime, you can just situate it on any base level OS, and it can create such an impact where AI computation could be standardized. And next we have efficient resource utilization. Since we're using an intelligent AI decision maker inside the hardware which is embedded, we can generally use it as edge. So in that way we can accelerate hardware utilization through this. And it is highly scalable, so you can just put it on any server, any system, and it can scale itself throughout the system. So these are the reference literature papers we use, and we can do some tests on how the simulation works. So instead of building the product directly, so what we did was we created a GPU simulator using Rust, and we implemented our scheduler, task, and priority to give it a baseline, a proof of concept that can be issued when delivering this project. So here it goes. So what we basically did was we ran a runtime scheduler simulation for RTOS using Rust, and we compared each and every single time, the average wait time, the average execution time, the total time, and how the scheduler performs with the AI runtime layer and without the AI runtime layer. And next we moved on to the metrics, which is again on different scenario. We use different kinds of schedulers, FIFO scheduler, and with varying duration, and we have priority scheduler. On different scenarios, how this GPU runtime layer performs compared with CPU and GPU. And this is we also had the simulation run in a crate, so this can be localized on a cargo and can be pushed into GitHub. So this is our project, so hope it runs. Thank you.